In this section, we're going to talk about transformations again, but more specifically just with absolute value. So if we think about the absolute value parent function, I'm just going to plug some values in here for x. And it's good to plug in negatives and positives so we know what the left side and the right side of the graph looks like. Well, we know absolute value is just measuring the distance these values are from 0, which is always a positive number. And you might recall from mod 1, we kind of already know what this function looks like graphically. It's just a v. Okay, this side has a slope of 1, this side has a slope of -1. So it's two lines meeting together at that vertex. The domain goes all values left to right, and the range depends on where this vertex is, where that v meets. So it starts at 0, and then it goes up forever. So 0 to infinity is our range. Okay, so remember, we kind of have 3 different possible transformations that can happen. We always start with the grouping symbol, which is going to be a horizontal shift. And remember, that's always kind of opposite of what we think. So if this is -2, it's going to move right 2, okay? And I'm actually going to point that more towards the H. Okay, then we move to multiplication, which is a vertical stretch or compression. And this could also be a reflection. So if it's negative, it's a reflection over the x-axis. And then K, the last thing we do is a vertical shift, up or down. And this one is as you would think. So if it's adding 3, it means we move up 3. If it's subtracting 3, we move down 3. Okay, so let's go ahead and try some transformations. So I'm not going to bother graphing my parent function here, you guys. We can refer back to this one if we need it. Sorry, I got a cord in the way here. Okay, so we are just going to describe the transformation and then the domain and range. So this one is subtraction outside of the grouping symbol. So this one is just moving down 5. So from our parent function up above, that means my vertex from 0 moved down 5. There is no vertical stretch factor, so that means my slope is still 1. So from there, I'm just going up 1 over 1, which is perfectly diagonal through the squares. And then -1 on this side, perfectly diagonal through the squares. So it's not any skinnier or wider. So my domain has not changed. The range now, though, my lowest value is -5 instead of 0. Okay? All right, this guy, now, no horizontal shift in the grouping symbol, so we move on to multiplication. So it's multiplying all my y values by 2, which is changing the slope. Instead of being 1 and -1, it's going to be 2 and -2. So my vertex is still 0, 0, but from there I'm going to go up 2 and over 1 instead of up 1 over 1. And then keep that going. So up 2 over 1, up 2 over 1. And then I'm going to repeat that on the left side so it reflects. I'm going to go up 2 and left 1. So this one has a slope of -2. And then connect. So this is a skinnier looking V because it has been vertically stretched by a factor of 2. So absolute values, that's affecting the slope. Domain, still all reals. Range, 0 to infinity. There was no vertical shift. So my lowest y value is 0. All right. Okay, this one we have multiple transformations, so we want to do them in the right order. So I'm going to move horizontally first. So this is going to move left 3. Then that -1 out front is going to reflect over the x-axis. All right, so we're going to move our vertex left 3. And that reflection, it's not anything other than 1, so it still has slopes -1 and 1. They're just opposite now. They're going up instead of out. Okay, so we're going to go down 1 over 1 each direction from the vertex. And then connect. So it should have the same width as our original parent function. It's just facing the other way because of that reflection, and it has moved left 3. Domain, all reals. Range, now it's going forever to negative infinity, and the highest y value it hits is 0. Okay, this one, grouping symbol first, so we're moving right 1, and then stretch by a factor of 2. So again, that's going to change our slope. So we're moving right 1, so vertex now at 1, and my slope's now 2. So up 2 over 1, and reflect that, go up 2 over 1 the other direction. And again, skinnier looking V due to that vertical stretch. All right, you'll notice the domain again has not changed. Range 0 to infinity. All right, this last one we have 3 different transformations. So first we are going inside the grouping symbol, so that's left 2. Okay, then I'm going to do this vertical compression and reflection. So vertical compression by 1/2 and reflect over x-axis. And then lastly, that addition or subtraction, so down 3. Okay, so now we are going to apply this. So we're going left 2, okay? Multiplying the y value here by negative 1/2 doesn't change anything, so it's still at 0, and then it's going to go down 3. 1, 2, 3. Okay, so now remember this guy affects my slope, but now it's going to be coming down this way because of that reflection. So negative 1/2. So that means I'm going down 1 and over 2. So this is going to be a wider looking one. So down 1 over 2. And I'm going both directions. And so it's wider looking because my slope is less. So it's less steep and it's a vertical compression. So this one's still all reals for the domain. Range, negative infinity, highest y value it gets to is negative 3. All right, last couple here, guys. So now we're given the graph and trying to write the equation that shows the transformation. Okay, so this one has obviously moved right and down, and it's a reflection. So how we tell if there's been a vertical stretch is we want to look at the slope. So here, the slope looks like it's just 1, down 1 over 1, down 1 over 1, down 1 over 1, okay? So the slope means it's just still 1, it's not been multiplied by anything, but because it's going the opposite direction, it has been reflected, so I need that negative out front. I'm going to use g of x since it's a different function, so I know I need a negative out front. Okay, it has moved from 0, it's moved right 3 and down 1, 2, 3, 4, 5. So right 3 means I need to subtract 3 in the grouping symbol, down 5, subtract 5 outside the grouping symbol. Okay, this one, I'll use a different function again here too. Let's call this one h of x. All right, this one, no reflection, but it looks skinnier, so I'm gonna check my slope. So here's kind of 2 nice points. So it's look like up 2 and over 1. So I know I need a 2 in front of my grouping symbol. Okay, it has moved from 0, 0, it's moved left 1 and down 1, 2, 3, 4. So left 1 is gonna be plus 1, and then down 4, subtract 4 outside. So this is probably the trickiest part to find, you guys, is that stretch factor. Again, the shortcut is just to figure out what the slope is from the absolute value graph. Okay, and I think that is everything for this section.